Hey AP Chemistry, I also wanted to post a brief video on fractions and algebra, just in case, because I don't want anybody to be behind because they don't know how to rearrange equations. So let's say, for example, I have something like 5 equals x over 2, and I wanted to solve for x. Well, there's this 2 hanging out with the x, and this 2 is in the denominator. And remember, if I have a fraction, that means it's dividing by the x, okay? So if I want to try and get that x by itself, I have to do the opposite function of what the 2 is doing to get rid of it. I have to multiply both sides by 2. And so if I do that, I'll have 2 times 5 equals x. And then, of course, that means 10 equals x. If I have the opposite, and I have 5 equals 2 over x. Now my x is in the denominator. And it's dividing by 2. And I could do the exact same thing that I did up here, but I probably have an extra step. So what I could do is, I could multiply both sides by x. And I'll get 5x equals 2. And then now I have 5 multiplying by 2. And I want to do the opposite function to get rid of that 5 to have x by itself. So now I have to divide by 5. So I'll get x equals 2 over 5. A bit of a shortcut here, right? So I know that x is 2 over 5. A bit of a shortcut, and you may see this in my answer key or work that I've done, is if I had 5 equals 2 over x, if I want to solve for that x, I'm pretty much just swapping the 5 and the x, right? Because look at that. If I swap the 5 and the x, I get x equals 2 over 5. So if I swap that x and that 5, I'll get x equals 2 over 5, which is what I got before, okay? So that's quick, like what I do with fractions and solving for an unknown. What if I had nothing but units, right? And so this is something that we are seeing in this chemical kinetics unit. But what if I had something like 500 equals 30 k to the minus first? Okay, and you may or may have not seen this, but I wanted to kind of show you where fractions in this business comes in. So if I have k to the minus first, remember, negative exponent means fraction for variable. Okay, so if I have k to the minus first, that's the same thing as saying 1 over k to the first. When I have an exponent in the denominator, that means it's a negative exponent. And where does this come from? Well, technically, another way of writing this would be like k to the 0 over k to the first. And what do we do with exponents when we have division? We subtract them. So this is technically 0 minus 1, which is negative 1. So this will be k to the minus first. That's where this comes from. So make sure you know that if you see 1 over k, it's the same thing as saying k to the minus first. So in solving this now, if I have 500 equals 30 times 1 over k, let's say I'm trying to solve for k for some odd reason. This k is technically in the denominator. It's being divided. So if I want to solve for k, I could do my shortcut where I could switch the 500 and the k, or I could multiply both sides by k. I'll get k times 500 equals 30. And then if I want to solve for k, I divide both sides by 500. And so k equals 30 over 500. Okay, so that is just crash course in algebra and units and what you do. What I have seen in problems on your practice set are if you have something like this. So if when you're using that activation energy problem, right? So let me flip to another page quick. So if you're using the activation energy problem and you get something like, in the end, you'll get 4.08 equals EA over 8.314 joules over moles times Kelvin. And then you do this and you get 0.000278 over Kelvin. Okay, and I want to solve for EA, and this is skipping a lot of steps. I'm going to show this work. If I want to solve for EA, right now I have 4.08, I have EA being divided by 8.314, and EA being times by 0.00278. So if this is being multiplied, to isolate, I need to do the opposite. I need to divide. So I need to divide both sides by 0.000278, 1 over Kelvin, 0.000278, 1 over Kelvin. So I'll get 4.08 divided by 0.000278, 1 over Kelvin equals EA over 8.314 joules per mole Kelvin, okay? And now remember what I said before, combining our first video. If I have a fraction in the denominator, I could do that like I'm multiplying by the inverse. So if I have 4.08, 0.000278, 1 over Kelvin, technically this is going to put Kelvin in the numerator. Kelvin over 0.000278. And this is going to be equal to EA over 8.314 joules per mole Kelvin. And then how do I isolate that EA? Well, I have EA being divided by 8.314. If I want to get rid of this 8.314 and have EA by itself, I got to do the opposite. I have to multiply to isolate. So I'm going to multiply both sides by 8.314 joules per mole Kelvin. I'll multiply this side by 8.314 joules per mole Kelvin. And so these will be able to cancel out. Just like up here, these were able to cancel out. And so if I kind of consolidate all of this in one, joules over moles Kelvin, 4.08 Kelvin over 0.000278. And this is going to all be equal to EA. I could either easily plug this into the calculator, but I want to make sure that you know the units. Joules per mole Kelvin multiplied by Kelvin, that Kelvin cancels out. So kind of an aside again with fraction, joules per mole Kelvin times Kelvin. If I have a number on the top or a unit on the top and it's the same as the unit in the bottom, they can cancel out. And so my EA units are going to be in joules per mole. And then eventually they ask you to convert that to kilojoules, but that's a different story. Okay, so consider this kind of a help with units. So please watch these two videos if you are one that is not the greatest at math and don't know how to work with algebra. And let me know if you need another video or another example of how I'm working with algebra to solve for units and numbers.